In this exercise, we will visualize an HorizonCube in a 3D by using a 3D slider and perform analysis along isotime lines. Then we will investigate Prograding system by making thickness maps and geobodies. Open the HorizonCube 3D Control Center from the icon. Select the active HorizonCube Continuous HorizonCube Full. Click on the Analysis, select 3D Slider and press Go. Keep the Horizon 3D Slider window open and close the Horizon 3D Control Center window. Add the default data for the inline 425. Right-click again on the inline 425. Add HorizonCube display. In the 3D slider window, click on Change and preload the HorizonCube Continuous HorizonCube Full, OK, and set the event range from 260 to 310 and OK. It is recommended to preload with limited range when using small RAM under 8 GB. And close. Set the top horizon display to none and base horizon display in full. Check the link to the 2D displays option to be able to see the HorizonCube event on a section within the selected range. And set the display data to top base isochron and press Calculate option. Notice the scene will be updated once you press Calculate button. Now change the top and base sliders to 302 for the top slider, enter to update, and the base slider 310, enter, and calculate. The results appear automatically in the 3D scene. Change the display to View North Z. This display an isochrone map between event 302 and 310 specified in the parameters. We can save the isochrone as an attribute under the base horizon, so save as event 310 isochrone and OK. So repeat the exercise for the following pairs. Top 285 and hit return, base 302, hit return, and calculate. Then save the isochrone under base and OK. Next, change the top to 275, hit return, and the base to 285, hit return, and calculate. Then save under base the isochrone horizon and OK. The last top 265, return, and 275, return and calculate. Then save as event 275 isochrone and OK. Now we can compare the different thickness maps and investigate the Prograding system. Right-click on 3D Horizon, Add, select the different 4 events with isochrone maps we just created. Change the z-value to isochrone map. Right-click on the z-value, select Attribute, Horizon Data, select the isochrone. Same thing for the next event. And the last event, Horizon Data, and OK. Close the HorizonCube 3D slider and start comparing the different isochrones starting from the base 310 event and going upward 302, 285, 275. we observe a shift in the depositional center. Bring back the HorizonCube 3D slider. For this exercise, we will apply a transparency threshold for all thinner region below a specific cutoff to preserve an outline of the thicker regions. Keep the parameters of the last isochron calculated between 265 and 275 event. At the bottom of the 3D slider, change the transparency to transparent below threshold and set the threshold value to 002. Hit enter. A thin vertical red line appears in the histogram which corresponds to the transparency threshold. Optionally, you can change the min-max and color bar. For example, we can set it to depths. Close the 3D slider window. Now you can create the geobody by pressing the Create Body button. Select Automatic Filling. The threshold is set to 02. Body value above threshold and run. Close the 3D slider window. The body appears in the 3D scene. Can change the color with the right mouse click and the display property and change the color. If you are satisfied with the geobody, you can save it by right-clicking on the new body one that shows on the tree and save as. Type in a name and OK. This concludes this exercise where we show how to visualize HorizonCube in a 3D by using the 3D slider and perform analysis along ISO timelines. We show as well how to make thickness maps and geobody to investigate Prograding system in a 3D.